I like RO say something.
Hello, welcome to week 12. I'm Mr. Dawit, your pre-calculus teacher. In week 12, you are going to learn about an arithmetic sequence. So please open your textbook to page 1123. At the end of the lesson, you should be able to find the common difference, the nth term of an arithmetic sequence, and also you should be able to find the sum of the nth term of an arithmetic sequence. In this lesson, you are going to learn what is an arithmetic sequence is. You are going to learn how to find the terms of arithmetic sequence, and also you are going to learn the general formula for arithmetic sequence and also its application. And you are going to use the arithmetic sequence formula in real life situation. And finally, you are going to learn how to find the sum of the nth term of an arithmetic sequence. So, dear students, please, at the end of each problem, you need to practice the checkpoint which is given in your textbook. So, these are the content of the lesson for week 12. Okay, now let's go to the definition for arithmetic sequence. An arithmetic sequence is a sequence in which each term after the first differs from the preceding by a constant amount. The difference of the consecutive terms, we call it common difference. Usually, we represent the common difference by a letter D. Now, this is the definition for an arithmetic sequence. Now, let's go to example 1. This example is from your textbook. Writing the terms of an arithmetic sequence. In example 1, you are asked to write the first 6 term of an arithmetic sequence in which a sub 1 equals to 6 and a sub n equal to a sub n minus 1 minus 2. That means here what's given, the first term is given, which is 6, and the recursive formula for the sequence is given. So in order to find the sixth term, what we need to do that, we need to begin with the first term. So the first term is given, which is 6. So to find the next term, which is the second term, what we need to do that, we need to plug 2 in n. So when we plug n 2 in the recursive formula, we'll get a2, which is the second term, will be a1 minus 2, which is 6 minus 2 is equal to 4. So the second term will be 4. By the same principle, we can find the third term. So to find the third term, we just plug n is equal to 3 in the recursive formula. So it will be, the third term will be 4 minus 2, which is 2. In another word, this is a sequence which can be found by adding a fixed value, which is negative 2, on each term. So we'll continue to find the fourth term. We just plug 4 in n. So when we plug 4 in n, you'll get a sub 4 is equal to a sub 3 minus 2, which is going to be 2 minus 2, which is 0. Then to find the fifth term, the same thing you'll do. Just plug 5 in n in the recursive formula. So you'll get 0 minus 2, which is going to be negative 2. The same thing you'll do to find the sixth term. So the sixth term will be minus 2, which is minus 4. So this is example 1 in your textbook. Please practice checkpoint 1 from the textbook. And if you have any question, you can discuss on our Schoology program. Okay, now let's go to example 2. Before I proceed to example 2, I just want to say a few points about the general formula for an arithmetic sequence. The general term of an arithmetic sequence is given by a sub n, which is equal to a sub 1 plus n minus 1 times d, where a sub 1 stands for the first term and d stands for the common difference. So this is a very important formula for finding the nth term of any arithmetic sequence. So you have to keep in your mind, this is a very important formula. Now, having said this, let's go to example 2. In example 2, you are going to practice finding the nth term using the general formula. Example 2 says that find the eighth term of the arithmetic sequence whose first term is 4 and whose common difference is negative 7. So this is very simple because the first term is given and the common difference is given and you are asked to find the eighth term. So to find the eighth term, simply plug the value of n, which is 8 n, and plug the values of the first term and the common difference in our general formula. So the general formula is a sub n is equal to a sub 1 plus n minus 1 times d. The value of n is 8, the value of d is negative 7, and the value of a sub 1 is 4. So when you plug it, you'll get a sub 8 is equal to 4 plus 8 minus 1 times negative 7. Then a sub 8 will be 4 minus 49, which will be, the eighth term will be 45. So in example 2, you are asked to find the nth term of an arithmetic sequence, given that the first term and the common difference. So in order to find the nth term of any sequence, you have to use the general formula. So this is example 2. Now let's go to example 3. Example 3 is the application of the arithmetic sequence in our real life situation. So again, example 3 is from your textbook. I'll read it. According to the National Education Association, teachers in the United States earned an average of $44,600 in 2002. This amount has increased by approximately $1,130 per year. From this problem, what you understand? Look, in 2002, on average, a teacher can earn about $44,600. So from this, what you understand? Yes, you can understand that 44,600 is our first term for the sequence. And in each subsequent year, the amount is increased by an amount 1,130, which means that this is a common difference. So here you have the first term and the common difference, so you can solve any problem regarding the sequence. So let's go to the first question. The first question, you are asked to write the formula for the nth term of the arithmetic sequence. This is easy. Since each subsequent year's teacher earning increased by 1,130, which is a common difference, is 1,130, and the amount that's earned in 2002 is our first term, so I can write the general formula for the arithmetic sequence. So, as we said earlier, the general formula for the arithmetic sequence is a sub n is equal to a1 plus n minus 1 times d. So simply I just plug the value of a sub 1 and d into our formula. So the general term will be a sub n is equal to 44,600 plus 1,130 and minus 1,130, which is finally I will get a sub n is equal to 1,130 and minus 43,470. So this is the general formula for the given arithmetic sequence. B. In question B it says, how much will US teacher earn on average by the year 2012? So in order to solve this problem, what you need to get? You need to get the value of n. To get the value of n, because our first term is, which is 44,600, which is the first term, is in 2012. After 11 years, it will be 2012. Therefore, the value of n will be 11. So simply, I will just plug the value of n, which is 11, in our general formula, which we get in part A. So A sub 11 will be 1130 times 11 minus 43,470. Then I will get 55,900, which means that the teacher in 2012, he can earn this amount. So this is example 3. Now I'll go to example 4. Example 4, it talks about the sum of the first n term of an arithmetic sequence. There is a general formula which is very important that helps you to find the n term of an arithmetic sequence. So the sum of the first n term of an arithmetic sequence is given by the formula S sub n is equal to n over 2 into A sub n plus A sub 1, where A sub n stands for the nth term or the general term, and A sub 1 stands for the first term of the sequence. So if you have the nth term or the general term and the first term of the sequence, you can simply find the sum of the first n terms of a sequence. So let's go to example 4. Okay, example 4, you are asked to find the sum of the nth term of an arithmetic sequence. Find the sum of the first 100 term of arithmetic sequence given by 1, 3, 5, 7. To find the sum of the first 100 term of this sequence, the first thing that you need to do, you need to find the common difference, the value of n, and the value of the first term, and you have to know the last term, which is the A sub 100. So let's see how we are going to find these values. So it is clear that the first term is 1. And to find the common difference, just take any term of the given sequence, any consecutive. It must be consecutive terms. For example, 3 minus 1. I'm just taking the difference of the second and the first. 3 minus 1, which is 2. So our common difference is 2. And the value of n is 100. So from this given information, I can find the general term. So let's find the general term, which is the 100th term. So our 100th term, I have to use the general formula. A sub n is equal to A1 plus n minus 1 times d. So our last term, which is the 100th term, will be 199. So here I have the 100th term, I have the first term, then I can find the sum of the first 100 terms of the sequence. So it will be S sub n is equal to n over 2 into A sub n plus A1, which is a formula. Then I just plug the value of A100 and A1. Then finally, the sum of the first 100 term of the sequence will be 10,000. So by this we finish the lesson. So if you have any question, you can ask me on our Schoology program. And also don't forget to practice the checkpoint question from your textbook. Thank you very much and have a nice weekend.